One of the most important parts of the hard drive is the disk arm. This arm is powered by an electric motor. The copper wire seen here was originally between two very strong magnets. The magnets are strong enough to pick up a pair of tweezers that I was using to take apart the hard drive. When current is sent through this copper wire, the hard drive arm will flick upward. The voltage supplied by the battery to the circuit was 12 volts. The initial resistance that I used was 810 ohms. I started at this high of a resistance to make sure that I did not destroy the engine. I then used a resistance of 560 ohms to try to produce a better result. As seen here, the arm moves about a third of the way across the disk drive. I continued to lower the resistance in an attempt to get an even better result and moved all the way down to 470 ohms. This created a movement about a half of the way across the disk drive. The next resistance that I tested the hard drive arm at was 330 ohms. As seen here, it makes the arm move all the way to the center of the disk drive. Even after acquiring this result, I decided to go down even further and try it at 180 ohms. This violently slams the arm into the center of the disk drive. I then decided to wire a 1200 ohm and an 800 ohm resistor in parallel and see if it produced the same result as the 470 ohm resistor. As seen here, the arm travels just about the same amount as with the 470 ohm resistor. While taking apart the hard drive, I noticed an interesting foam slip between two of the key components. I determined this to be an insulator because when I touched the two prongs of the voltmeter together, with this in the middle of them, it did not read any voltage. Just to recap, when I connected the battery, the resistor, and the motor winding in series, I formed a circuit for current to flow. It is apparent that the motor arm moves further as current flows because with a constant voltage, smaller resistors produce more movement, and by E equals IR, that means that smaller resistors produce more current and more movement. Current flowing through the coil of the arm produced a magnetic field which interacted with the permanent magnet to produce movement. Because I had a recent disk failure, I had a spare hard drive that I could experiment with. Thank you for watching this physics point of interest.